All right, good Wednesday morning. This is Mr. Alexander. Hope you guys are doing well. Today's lecture is going to be entitled Network Protocols and Standards. The first slide that we're going to talk about is entitled Rules that Govern Communications. So as we look at this slide, we can see a few things. We see that two people are trying to talk to each other, and one gentleman is trying to get a specific question to the other gentleman. And the question is, where is the cafe? When we look at the protocols that were being used, where is the cafe? That's really the transmission. That's the data. That's the question at hand. Below that, we have all of the different rules that we use to ask this question. Are we using English? Is it my turn to speak? How do I know when the other person is done speaking? So there are rules of the communication that we talked about yesterday. And down at the very bottom, we have the physical layer, the actual vocal transmission from your vocal cords into the airwaves and into the ears of the other person. So this is called, or this gives the idea of a stack of protocols that are layered on top of each other. And we're going to call layered protocols like this a protocol suite. So a stack of protocols is a protocol suite, and they work together to help solve a problem. And in our cases, the problem is communication on a network. So when we're talking about network protocols, we're going to talk about a variety of things, including how the message is formatted or structured. It depends upon your media type to how the message is going to be formatted or structured. If you're an Ethernet frame, you're significantly different than a wireless frame, or you're even different than a WAN frame. It depends on the media which you're traveling through to how that data is packed up. Network protocols can help us understand or help networking devices share information about the networks that they know. So having a protocol like Open Shortest Path First routing protocol shares updates with all the routers it's connected to about what paths that it knows to other distant networks. How and when error and system messages are passed between devices. This could be easily described as a TCP timeout when you're going to ask for a web page and some of the data doesn't get to you. The sender actually asks you, did you get that data? And you say, no, I haven't received that data. So the sender resends that specific piece of data to you. And then also the setup and termination of data transfer sessions, how we create the establishment of a session between, say, a client and a web server. So in this, we're going to look at this protocol suite, and we're going to put it in a hierarchy as well. Way up at the top, we're going to call this the application protocols. And in this example, this is you're going to look at a web page, and you're going to try to get a web page that you know is an HTTP. That's the hypertext transfer protocol that the web page uses. It's written in HTML. You use websites all the time. To get to that web page, it has to be delivered to you, and it is going to be delivered to you through the use of TCP, which is the Transmission Control Protocol. Again, going back to IT Essentials, that's the protocol that checks to make sure that the message and all of the little pieces of that message were delivered to you. Obviously, we're using internet, and that means we're going to be using IP addresses, so that message is going to be routed using IP addresses, and once it gets into your LAN, the network access protocols take over, and that message is going to be forwarded to you based on MAC addresses through Ethernet. So this is a simple idea of a protocol suite. What protocols are used in this specific transmission on this page of a web page? Now, when we look at protocol suites, when networking was developed, the first network was created in 1969. We'll talk about that in just a second. But from 1969 to where we are now, we're looking at roughly 45 years of time between then and now. And in that time, there's been a lot of different networking concepts that have been developed. The one that we all use today is the TCP/IP protocol suite. If you look to the left, you'll see the TCP/IP protocol suite, including such things as HTTP, DNS, DHCP, FTPs. Those are the applications. The TCP and the UDP are the transport layer protocols. IP down there is what the network layer protocols, IPv4 and IPv6. And down below at the bottom, we have a whole bunch of different mediums. Now, the mediums are going to be the same regardless of of your networking type. Now, like we said, TCP/IP is the one that is used today. It is the one that basically one evolved faster and better than the others. Some of the older networking standards that were used, ISO, AppleTalk, obviously was invented by the Macintosh people, and it held their networks together for some time until they basically adopted the TCP/IP protocol suite. And another player in networking was Novell, and Novell NetWare had been around for a while, and the IP layer was IPX. So you might see that somewhere along the way in our Cisco books. But basically today, the only real protocol suite that we will be concerned with is the TCP/IP. All right, so let's talk about this creation of the internet and the development of the TCP/IP. So the first network was designed by ARPANET, or by ARPA, which is the Advanced Research Project Agency, and their network was called ARPANET. And it was first connected together in 1969 by 4 mainframe computers at 4 different locations across the United States. This project was a project sponsored by the Department of Defense, and it was used for research and for universities. This network held the very first router, and that first router was known as the Interface Message Processor, the IMP. So that's 1969. In 1973, Robert Kahn and Vince Cerf began to work on TCP, which is really pushing the evolution of this ARPANET. And TCP, again, is Transmission Control Protocol, how things are sent on a network. So from TCP, was designed to replace ARPANET's current program, which was called Network Control Program. And in 1978, TCP was divided into 2 protocols, TCP and IP. So later, lots of other protocols were added to this suite of protocols, including Telnet and FTP and DNS and all of the other protocols that we've been speaking about. Looking at this TCP/IP protocol suite, this is what we see. Up in the application layer, which is closest to you, the things that you interact with or the things that your computer interacts with on a daily basis, such as DNS. And you should know by now that DNS is when your computer asks for a website by name, www.google.com, your local or your distant DNS server takes that request and changes it into the IP address that you need to get to that website. That is DNS. Your host configuration protocols, DHCP. Again, you should know by now, when you turn your computer on, it goes out and it finds an IP address. That is done through DHCP. Above DHCP in this picture, you've got BootP, and BootP was a predecessor to DHCP. You may see that on an interface, maybe on a printer, every now and then, just an older version of DHCP. You've got your email protocols that we've talked about, SMTP, POP, and IMAP. You've got your file transfer protocols. You have FTP and TFTP. When you download something from the web, typically you're dealing with File Transfer Protocol, FTP. We will use Trivial File Transfer Protocol in moving operating systems from routers and backing those up here at the end of this book. You obviously know what the web is, it's HTTP. So moving down the TCP/IP protocol stack from the application layer, we go down to the transport layer. Our 2 transport layer protocols are UDP, User Datagram Protocol, and TCP, Transmission Control Protocol. Again, referencing IT Essentials, we should have a little bit of an understanding that TCP checks to see if you got the small frames and resends them if you did not, whereas UDP does not, and UDP is used for things such as streaming video and voice over IP. Going down the stack, we get to the internet layer. Down at the internet layer, we have NAT. NAT we will learn to configure a while later. That is called Network Address Translation. That is where your router takes those internal private IP addresses that you have on your internal network, 192.168.1.10, and it translates it to a real routable IP address. ICMP, we have talked about, we have used prior. We will typically refer to ICMP as the protocol that props up such things as ping and traceroute. They use that protocol in order to check connectivity and to trace the routes. Other protocols at this layer include your routing protocols such as RIP, OSPF, EIGRP, and BGP. And routing protocols are just simply when routers talk to each other about the networks that they know. Moving down, you have the network access layer, which is where you access the network and how you access the network. And that's that encapsulation that we were talking about previously in these slides, whether it's Ethernet or whether it's a WAN link or whether it's a wireless link. And the network access layer also includes all of your physical equipment and your interfaces as well. When looking at these protocols were developed by somebody. And there are a lot of different organizations out there, worldwide organizations, that work on these internet standards. Um, Here are some of these organizations: the Internet Society, ISOC. The one that you've probably seen before is the Institute of Electrical and Electronics Engineers, IEEE. Triple E's greatest hits are coming up with the Ethernet standard 802.3 and the wireless standards of 802.11 that you all know and love. They've got a lot of other standards that they've helped to create along the way as well that you can see on this slide. Um, Another one specifically that you've probably used before is your personal area networking, where you're connecting with your Bluetooth mouse or keyboard. You may be even using that now. Okay, one of these organizations came up with the OSI model, a protocol suite which allows us to better define the TCP/IP in terms of layers to help us with troubleshooting. In this OSI model, we need to very specifically know each layer of the OSI model. So if you haven't committed that to memory yet, today's a good day to review that. At the top of the OSI model, we have the application layer, followed by the presentation, session, transport, network, data link, and physical layer down at the bottom. Notice they are labeled, they're numbered. So 1 is physical, 7 is application. So it goes in that order, from top to bottom or bottom to top. So we will reference this OSI model often as we move forward, and in all actuality, this book is chapter by chapter look at the OSI model, starting at layer 1 and moving up until we get to layer 7. So that is what you can expect for the rest of this year in school. We're basically going to be going through the OSI model piece by piece and learning each layer very detailed. Again, the older TCP/I reference model consists of 4 layers: application, transport, internet, and network access. Both of these models are describing the TCP/IP protocol suites. The OSI model is just a little more layered. It has a little more nuances per layer, so it allows us to troubleshoot things at specific layers a little bit easier than if we were looking and using the TCP/IP as a reference for this. It also helps vendors focus specifically on the layer for their device that they are creating the device for. Comparing the two models side by side, the TCP application layer encompasses the application, presentation, and session of the OSI. Transport layers are exactly the same. Network and internet layers are exactly the same. And the network access layer, the TCP/IP model, is basically the same as the data link and the physical layer on the OSI model. So let's take a look at where these applications that we talked about fall earlier in terms of both the TCP/IP and the OSI model. Again, applications are going to be falling in the top layer. The stuff that you interact with, the stuff that you see, the stuff that your computer does because you tell it to do, those are applications. That's going to be at the top of either of the protocol suites. Moving down, we got the TCP, UDP, the transport, the IP stuff, and the internet, and the ICMP stuff in the internet and network. And down below we have those encapsulations, and we have the physical things as well. Okay, so let's talk about some assignments for today. It is Wednesday. You should have a lot of stuff done from yesterday. What's going to happen today? You're going to have Chapter 3 Reading Guide Part 2 come out. That is going to be a solo project. Again, it is due today. Doesn't matter what you haven't done from previous classes. It doesn't matter how far behind you are. If you do not do this particular reading guide today, you will not get points. The next assignment is Packet Tracer, investigating TCP, IP, and OSI models. You can work with partners on this. I do need you both to fill out different PDFs, but just have a partner along if you have any questions or if you guys need to think about something to figure it out together. This is not one PDF per two people. You each individually need to fill out PDFs and send those to me. And lastly, you have a lab for researching requests for comments, RFCs. When these protocols that we talked about were developed, the process is as such. A person or an organization will develop a protocol, then they will put the protocol out there, and they will have other people comment on it and see what changes need to be made, see how other people view their work before it becomes an accepted protocol. So that is a request for comment. So you will do that as well. I'm a fan of the pigeon. That's all I'm going to say on that. Anyway, all of these assignments are due today. They will not be accepted after today. So I hope you get them done. There's a couple good things in there. So have a good time, and I will talk with you on Thursday.